Welcome everyone. My name is Sumesh Balakrishnan. I'm part of Enterprise Manager Product Management team, and joining with me is Anna McCullum, Senior Director of Product Management. Today, we will talk about streamlined database monitoring with next generation agents. In this session, we will explore the evolution of Enterprise Manager, which now enables remote monitoring and management of targets without the need of deploying a local agent on each target. Our agenda for today's session will focus on addressing the challenges faced by administrators in agent lifecycle management and exploring the capabilities of remote target monitoring using the next-gen agent. So we will see the challenges administrators are facing with agent lifecycle management and an overview of remote target monitoring and remote monitoring topology and next-gen agent deployment setup and remote host addition and monitoring. And finally, we will see how to discover and remote monitor of database targets. Before we dive into the power of next-gen agent, let's take a moment to review some of the common challenges that administrators face with agent lifecycle management. We believe at a macro level, there are three key challenges. First one is agent complexity. One of the key challenges in agent lifecycle management is the complexity of managing agents across different geographies and heterogeneous platforms. Deploying and configuring agents on host system can be time-consuming and a complex task. In upgraded environments, there may be multiple agent versions requiring management and maintenance. And also, securing agents for secure communication with Enterprise Manager adds an additional layer of complexity. The second challenge is tied to configuration pollution. Configuration sprawl refers to the proliferation of agents configuration within an organization. With numerous variants of agents created by different users, it becomes challenging to manage and maintain consistency across configurations. Configuration variations increases the risk of misconfiguration and can lead to higher support cost. Third challenge is tied to agent maintenance. Keeping agents up to date with the latest patch level and upgrades poses a significant maintenance challenges. As the number of agents in the system grows, the maintenance cost, including availability, patching, and upgrades, also increases. Administrators often spend a lot of time in managing and maintaining these agents. There is a need for an efficient solution that can effectively manage agents at scale, reducing maintenance efforts. These challenges highlight the need for a streamlined and efficient approach to agent lifecycle management, which the next-gen agent aims to address. Given the challenges mentioned earlier, which one would you prefer to use? Deploying individual agents on each target host, such as host database to manage them in Enterprise Manager, or deploy the next-gen agent to monitor all target types such as host, database to manage them in Enterprise Manager. Deploying the next-gen agent for remotely monitoring and managing targets seems to be the better option. Let's explore the capabilities of the next-gen agent and how it improves the ability to manage and monitor targets remotely. The primary goal of next-gen agent is to facilitate effective remote monitoring and management of targets without the need for deploying a local agent on the host. This approach aims to streamline the agent lifecycle and enhance manageability while reducing the agent footprint in the system. Implementing a next-gen agent for target monitoring offers several benefits, including improved manageability and reduced reliance on local agents. By leveraging the next-gen agent, we can effectively monitor and manage targets in a more efficient way. In the current Enterprise Manager setup, agent failure acts as a single point of failure and adversely impacts the monitoring of critical targets. To address this issue, high availability support is provided for the next-gen agent. In the event of next-gen agent failure, a standby next-gen agent is available to ensure the continued monitoring of critical targets. The next-gen agents are an extension of the standard agents we currently use in Enterprise Manager. However, they are specially configured to enable remote monitoring of targets deployed across multiple regions from a centralized location. This allows for more efficient and effective monitoring. The remote target monitoring through the next-gen agent is divided into two phases. In the first phase, we focus on remote monitoring of databases and host targets. In the subsequent phase, the next-gen agent will provide support for database lifecycle management and high availability. Additionally, it will also offer the migration support for moving targets monitored by local agent to the next-gen agent and vice versa. Let's dwell into the topology of remote target monitoring using the next-gen agent. We will explore the steps involved in deploying the next-gen agent on a remote host and how it enables us to monitor and manage targets effectively. To begin with, imagine we have our enterprise manager already deployed. We now have a new remote host that we want to provision for the next-gen agent. The host is equipped with all the resources for optimal performance and efficiency. Here, for the deployment, we will use the agent push mechanism from the OMS to deploy the next-gen agent on the remote host. For the agent push to work, we need SSH connection from the OMS to the next-gen agent so that we can transfer the agent software and run the agent configuration. The agent configuration step will configure it for the next-gen agent. Once the next-gen agent is deployed, it will include the host targets. Now let's consider a scenario. We have two remote hosts, host 1 and host 2, with database 1 and database 2 deployed on them. We will now explore how to remotely add and monitor these database targets through the next-gen agent. The addition of remote host to the next-gen agent is initiated from the OMS onto the remote host. So we create the remote cache and remote cache SMIN directories. The detailed path and contents of these directories will be discussed in later slides. Once the remote hosts are added to the next-gen agent, it will begin monitoring them. The next step is to discover the database running on that host through the next-gen agent for management and monitoring purpose. For the direct connectivity and displaying database performance pages, the OMS established a direct connection to the remote databases. This enables us to view the performance pages of databases seamlessly. So throughout the process, it is essential to understand the different communication channels at play. We have established the SSH connection from OMS to the next-gen agent for next-gen agent deployment. And OMS also established a direct connectivity to the remote databases for monitoring purpose. This gives you a visual representation and a high-level topology diagram showcasing the remote target monitoring using the next-gen agent. Let me share with you the simple and efficient process for monitoring remote targets, which is database or host, through the next-gen agent. This process consists of 3 simple steps that allows us to effectively monitor and manage these targets. Let's explore the steps in detail. The first step is to deploy the next-gen agent. Here, we offer 2 methods for deploying the next-gen agent. One is through the agent push mechanism, and the second is through the EMCLI method. The second step involves adding the remote host target to the next-gen agent. We have a guided mechanism that simplifies this process, making it easy to add remote host to the next-gen agent. Additionally, we also have EMCLI method provides another option for adding remote host targets. Finally, we have the normal discovery of remote targets such as databases or databases through the next-gen agent. This discovery process allows us to identify and gather information about the remote targets. Once discovered, we can promote these targets for target monitoring. This ensures that the next-gen agent effectively monitors and manages the remote targets. Let's look into the first step of deploying next generation agent. Before we dive into the deployment procedure for the next-gen agent, let's go over some of the important prerequisite checks. These checks ensure a smooth deployment process and help us understand the capabilities and limitation of the next-gen agent. Firstly, it is important to note that the next-gen agent is currently supported only on the Linux x64 platform. When designating a host for next-gen agent deployment, make sure it does not contain any targets like database. The host should be empty, allowing the next-gen agent to focus solely on monitoring the host itself and serving as an agent target. In the initial phase, the next-gen agent will support only database and the related targets. So keep in mind that other target types like middleware or e-business suite or Golden Gate are not supported by the next-gen agent for monitoring purposes. In the initial phase, the next-gen agent lifecycle is supported through agent patch plan. In the future phase, we will support gold image-based next-gen agent management for patching. It's crucial to select a new host specifically for next-gen agent deployment when setting up remote target monitoring. Existing local agents cannot be converted into next-gen agent in the initial phase. Here, we will explore the setup process for deploying the next-gen agent using the agent push mechanism. It is important to note that this deployment setup ensures a seamless user experience as we maintain consistency with the existing agent push method. Let's walk through the steps involved in deploying the next-gen agent. When deploying the next-gen agent, you will notice that we have preserved the familiar user experience. That means in the Add Targets Manually page, you will find an option to install the next-gen agent. This means that the overall deployment flow remains the same as the agent push method, ensuring a smooth transition for the users. To enhance further the deployment process, we also provide an EMCLI method for deploying the next-gen agent. So here you can see the EMCLI command to deploy the next-gen agent. Once the next-gen agent is successfully deployed, you can review the deployment results by clicking on the results button. This provides visibility into the deployment status and ensure that you have a comprehensive view of the deployment process. In the first step, you have seen setting up the next-gen agent deployment on the host. Now let's move on to the next step, which involves adding remote host target to the next-gen agent. So we will look into the simplified flow to accomplish this task effectively. Let's look at the UI flow for more details. The navigation path will be setup, add targets manually, add remote host targets. The first option you will see is to select the next-gen agent in your system to add the remote host for monitoring. The eye icon next to that will display the resource utilization of the host to let you know the current utilization before you add the remote host. The next is the monitoring credential. This is the normal OS host name credential that supports SSH key-based and user password combination. These credentials will be used for monitoring. All metric executions will use this credential. The OS user specified in the monitoring credential has the same requirement as the next-gen agent install user in regular EM agent installation. Example, the O-install OS group. The next is the host admin credential. This is the root credential for the remote host. This also supports SSH key-based and username and password combination. This credential will be used for remote cache management of root-owned executables, such as SBIN content. We also require the PDB settings and the SSH port to be open on the host. Either you can pre-create this credential or you can click on the plus icon to create a new one while you are adding the remote host to the next-gen agent. The next option is the remote cache. A remote cache location on remote host is a cache of scripts, archives, monitoring utilities, and application metadata and monitoring executables and utilities needed for monitoring and management of targets on remote host. The next-gen agent will also initiate scheduled tasks that will maintain this cache. There is a scheduled task that checks if a cache needs to be updated. So remote cache contents will have something like utilities like zip, unzip, archives like JSCH jar files, etc., and scripts like admin scripts. Remote cache location also contains the Perl and JDK that is maintained in this location. So the minimum space required for remote cache location is 1 GB on remote host. The next is remote cache SBIN location. This directory contains SBIN contents that needs to be pushed to a directory that is owned by root and writable only by root. Remote cache SBIN location contains the utilities like nmosudo and nmgsshi. This is the location of the root-owned content on the remote host. The agent needs certain root-owned executables for remote target monitoring. Again, the minimum space required for remote cache SBIN location is 1 GB on the remote host. Next is the add button, where once you click on add, you can add all the remote hosts that you want to add to the remote agent. So you can provide all the host details here, and then here you can do a review of all the inputs that you have provided in the previous screen. And once the review is all done, you can click on submit. Or if you would like to modify any parameters or any location, you can always click on the back button to go back, modify your parameters, and you can come back, review, and do a submit button. We also have a command line option to add remote host to the next gen agent. So once you submit the add remote host to the next gen agent, the job gets submitted. And here is an example screen to show the various steps that gets executed as part of the remote host addition process. At this stage, the next-gen agent is deployed and the remote host is added to the next-gen agent. Now let's move on to the next step involved in managing and patching the next-gen agent for optimal performance and security. These steps will help you to identify the next-gen agent in the system and keep them up to date with the regular release update process. Within the Enterprise Manager console, you can access the Manage Cloud Control page. Here, you will find a section that displays the agent type, indicating whether it's a normal agent or next-gen agent. This identification feature is designed to help users easily identify and distinguish the number of next-gen agents present in the system. This allows for better management and monitoring of the deployed agents. Once the next-gen agents are in the system, it is important to keep them patched with regular release updates. This ensures that the agents are up to date with the latest patches, maintain compatibility with the JDK, and also incorporate any necessary security configurations such as importing certificates, configuring cipher suits, etc. To patch the next-gen agents, you have two options. First, you can use the agent patch method. Alternatively, you can use the standalone command line patching to patch the next-gen agents. Here, we transition into the last and final step on how to discover and monitor the targets using the next-gen agent. To go over this section, let me turn it over to Anna McCallum to go and cover in details about the discovery and monitoring of targets. Thank you.
Thank you, Sumesh. Before we get into details of discovering targets, let's get a big picture overview of the end state for remotely monitoring your database targets. Let's say you have these databases that you want to monitor in EM. Some part of your database fleet is in one data center, and the others are in a second data center. Furthermore, you can have a primary database and its ASM and listener targets in one data center, and its standby in a second data center. The general guidelines are these. A database and its related targets should be monitored by the same next-gen agent if they are in close network proximity to the agent. If they are not in close network proximity to the agent, such as the standby database, which is in a different data center, then use another next-gen agent in that data center to monitor those targets. Going by these guidelines, we use Agent 1 in Data Center 1 to monitor the primary database and its related listener, ASM targets, etc., as well as other databases in Data Center 1. We don't use Agent 1 to monitor the standby because it is not close in network proximity to Agent 1. Instead, we use another agent, Agent 2, in Data Center 2, to monitor the standby database because it is in close network proximity to the standby. Here are the general steps for discovery. We assume at this point that your next-gen agents have been deployed using the process outlined by Sumesh. To discover and monitor the database and its related targets, first determine the agents that will be used to monitor these targets. As mentioned, choose the same agent that is close in network proximity to your targets. Then add or discover all of the hosts of the database and its related targets to the same agent. So if you're discovering a 2-node rack, add both nodes or hosts of the rack to the agent. Use the process outlined by Sumesh for adding these host targets. Next, add the database targets using the same discovery workflow that you would use if you were using a local agent. All database discovery options are supported. This includes auto-discovery, guided discovery, manual discovery, or discovery using EMCLI. As an example, let's walk through the guided process discovery workflow. First, choose the Oracle cluster and high availability service. Next, it will ask us to choose the host on which the cluster resides. Here, we choose the appropriate host, which has already been discovered and is now remotely monitored by the next-gen agent. The remaining workflow is the same. You fill in cluster target property details such as scan name, scan port, etc., and follow the next steps to discover the cluster and the high availability service targets. Let's look at the discovery of the Oracle database. From the guided process list, we choose Oracle database, listener, and ASM. Next, it asks us for the hosts on which these targets reside. We choose the host which has already been discovered and is being monitored by the next-gen agent. The remaining discovery workflow is the same. It will go through the process of discovering the database instances, ASM instances, which you can then later choose for target promotion. After discovery, all database monitoring features that you already use with locally monitored targets will work the same way as remotely monitored targets. These include metrics, thresholds, monitoring templates, metric extensions, corrective actions, blackouts, etc. Hence, your existing monitoring setup that includes your monitoring templates, metric extensions, corrective actions, all of these will work seamlessly on your remotely monitored targets as well. It's not only monitoring that is supported with the next-gen agents. We also support performance diagnostics, jobs, and most management operations such as backup, data guard failover, switchover, etc. All of our database and database-related target types are supported with these operations. DBLM, or database lifecycle management operations, such as patching and provisioning, are scheduled for future phases. Let's talk a bit more about remote host monitoring using the next-gen agent. Remote monitoring of a host begins when the next-gen agent receives information and credentials to the host. With a local agent, if the host is down, the agent, host, and its targets go into agent unreachable status. With remote monitoring, the host can go down and the agent can still be up. If that occurs, or if there are connectivity issues between the agent and the host, then the remote host goes into host unreachable status. The status of the target on the host will be in error with an appropriate message, and the jobs on the host will be suspended. To let the appropriate administrator know about this scenario, we recommend that you create an incident and send notifications for the host unreachable status for your host targets. If the next-gen agent itself or its host go down, then the agent and its monitored targets go into agent unreachable status, which is the same behavior that you see now with the existing EM agent. Here are the benefits with remote target monitoring and management with the next-gen agent. Simplified next-gen agent deployment provides a reduced agent footprint, which saves administrators time and efforts. Because the agent no longer needs to be co-located with the database host, this reduces resource consumption across your enterprise. With less agents to manage, administrators have more time to focus on database monitoring and management activities. And finally, EM provides an easy way to track the agent's overall health and manage your lifecycle. Thanks for joining our session today. For more information on Enterprise Manager, here are links to our webpage, videos, and other resources.